Hello again, boys and girls. Want to start off by showing off some work that was turned in by Alice Rodriguez and Matthew Sanchez. They both did a great job on our week 4 day 1 problem, showing their launch strategies. Great job using the computer there, Alice and Matthew. We just missed a 1 in the thousands, but I knew what you meant. You both did a fantastic job. Thank you guys for turning it in. We got some other work in, but these are the two that I wanted to show for today. We'll be sure and get some more problems in there for the rest of the week. But awesome job, you guys. Keep up the great work. All right, so jumping into our answer for our day 2 problem, there were 488 kids at the playground. Some kids arrived at the playground an hour later. Now there are 721 kids at the playground. How many kids arrived at the playground? Okay, so I'm going to start using solve, but I'm actually going to also, I'm going to finish by using this work by Nathaniel Alvarado. Nathaniel Alvarado, you did a fantastic job with this, and I just want to kind of highlight some of your work there. But let's begin by using the solve model. What we know is that there was 488 kids to start. Some kids arrived, and now there are 721 kids at the playground. Before going into our launch, I just want to show that when we organize this problem is a join problem. We've got all these kids at the playground, and we've got some more that joined in. Now we have even more kids at the playground. So if you look at the action that's happening in the story problem, the action is that some kids are coming into the playground. So they're joining the kids that were already there. That does not mean, though, that we're adding. We're actually going to subtract here. And Nathaniel did a fantastic job of using some algebra to show us our unknown, right? That x that he used right there is his unknown. We have 488. Some kids that were unknown joined, and now there are 721. So Nathaniel did his best to show us his math. Don't forget, Nathaniel, that whenever you're subtracting, that bigger number's got to be on top. So you got the right idea, because you can't have negative kids. So good job on that. But we'd have 721. That's not good. Let me go back here just a second. Change up our color, maybe green. Okay, so we have 721, and we're going to subtract 488. And the answer to that is 233. How do I know? Well, I've got to regroup. Got 11 minus 8 is 3. Got to regroup from the hundreds. I already had one, so 11 minus 8 again is 3. 6 minus 4 is 2. So yes, the correct answer is 233. Now I know this was a little unconventional. I didn't use the exact solve model, but Nathaniel did such a good job showing his work here that I absolutely had to use it. Great job. Thank you for turning that in. Just absolutely amazing. All of you guys are doing a fantastic job, and I want to continue highlighting your work. All right, now let's go into our guided problem for today. There were some kids at the playground. We don't know how many started. 35 kids arrived. Now there are 72 kids at the playground. How many kids were at the playground first? So remember, first things first, for me, I got to follow the steps because I want to stay focused here. And I know sometimes we think, oh, but I already know the answer. I know, but hold on a second. We got to slow down and let's go back to our question. How many kids were at the playground first? So I'm going to go to verify because I want to make sure I stay focused. Unknown kids were at the playground. Okay, so that keeps me going in the right direction. Now let's think about what's happening in the problem. There were some unknown kids at the playground. If some kids arrived, then more kids are coming. So there's 35 kids coming, and that gave us 72. Now, remember, there are some kids there. We don't know how many. More kids came to the playground. Okay, great. This is a join problem. But is a join problem where our start is unknown? We don't know how many kids were there. Well, I could guess at how many kids were there, but it's so much easier to use our fact family and subtract 72 minus 35 to give me our start that's unknown. So let's do that. 72 minus 35. Let me regroup. I already had 2, so 10 ones, and the 2 that I already had, 12 minus 5, it was 7, and 6 minus 3 is 3. So according to our calculations, we have 37 kids that were at the playground originally. Now I want to talk for just a second about our E for extend, because we haven't really gone into E for extend very much. So notice that we started with an equation that we could not solve. We used fact families, though, and the inverse operation to get us to an equation where we could solve it. Now our extend could be something like, oh, I know that I have a whole of 72, and there were some kids that were there. I don't know how many there are, but there were 35 that came. So if we use that part whole model, that'll help us extend the problem to solve it in a different way. We could draw it out. We could use counters, things like that. So that's kind of, I just wanted to go over briefly what we could use that extend section for. Now, I hope this helps you out in today's problem. Please keep turning those that work in, whether it be online or through pictures. You guys are doing a fantastic job, and I hope you guys are staying safe and healthy, and I hope you have a fantastic day.